this final Hello again, and welcome to our final module on clean architecture. I'm Matthew Renzi with Pluralsight, and in this final module, we'll learn how to evolve our architecture over the life of the project. As an overview of this module, first we'll discuss how we can evolve our architecture to reduce risk due to uncertainty and changing requirements. Next, we'll discuss where to go for more information if you'd like to learn more about the topics in this course. Finally, we'll wrap up this module and the course as a whole. What we've seen so far in this course isn't the end goal of this set of architectural patterns, practices, and principles. Rather, it's just the beginning. What I've attempted to define is a starting point for building modern applications that will benefit from this set of practices. These are typically applications built using agile software development practices in an environment with a high degree of risk due to uncertainty and changing requirements caused by changing technologies, changing markets, and changing user preferences. This means that the architecture needs to evolve to minimize this risk due to uncertainty and to meet these changing requirements. By placing focus on the key abstractions of the domain and application logic at the center of the architecture, and deferring user interface, persistence, third-party dependencies, and cross-cutting concerns to implementation details, clean architecture allows the application to more easily evolve over time. When we're making these implementation decisions, we want to defer these decisions until the moment known as the last responsible moment. This term was coined by Mary and Tom Poppendieck in the book Lean Software Development and Agile Toolkit. The last responsible moment is a strategy for avoiding making premature decisions by deferring important and difficult-to-reverse decisions until a point in time where the cost of not making the decision becomes greater than the cost of making the decision. By delaying these decisions until the last responsible moment, we increase the likelihood that we are making well-informed decisions because we now have more information. Making implementation decisions too early can be a huge risk on some projects. However, waiting until after the last responsible moment, as the name implies, creates potential risks and technical debt as well. Evolutionary architecture practices are about creating architecture that allows us to more easily defer these decisions until the moment where we've minimized the risk due to making the decision too early, but not waited too long and accumulated technical debt. For example, by focusing on the domain and application logic and solving the key problems that our users need to solve, we can validate whether or not our software will actually provide real business value to our users before we invest heavily in the implementation details. In the meantime, we can just use the simplest solution that could possibly work for each of the implementation details. Just enough to get us by while we validate the primary value proposition of the application, that is, whether or not our software will provide real business value to our users and our business. In addition, technology will likely change over the life of the project. For example, during the course of a project, a new type of database technology may eventually be released that makes more sense than using the database technology that we had previously decided upon. Clean architecture makes it much easier to defer implementation decisions or replace existing implementations than an architecture built around a specific implementation. Markets may also change over the life of a project as well. For example, a simple client-server application designed to support a few hundred users might balloon in demand to millions of users and need cloud-scale CQRS and microservices to support the new workload. With clean architecture, we build a solid domain and application core first, and then scale that core as large as necessary if and when the need should arise. User preferences may also change over the life of a project as well. For example, we might discover later on in the project that users now want a mobile user interface rather than the desktop user interface that they'd previously desired. With this style of architecture, we can easily swap out presentation technologies or support multiple user interfaces built upon the key abstractions in the domain and application layer. We want our application architecture to be flexible by default to help protect us against the unpredictability of the future. These architectural patterns, practices, and principles that we've just learned give us this kind of flexibility and adaptability. So why would we want to create an architecture that evolves over time? First, evolutionary architectures embrace uncertainty. If you're building an application in an environment with a high degree of uncertainty, it's better to have an architecture that can evolve as you learn more over time than to try to predict the future and build a rigid architecture based on those likely to be wrong predictions. Second, evolutionary architectures embrace change. It's inevitable that on most software projects, the requirements will change over the life of the project. Having a flexible architecture allows the architecture to adapt to these changes. Finally, evolutionary architectures help us to reduce certain types of risk. If uncertainty or changing requirements are the biggest risk to your project, which has been the case with most projects I've worked on over the years, then optimizing your architecture for adaptability helps you to reduce this risk. So why would we not want to build an evolutionary architecture? First, if you have a project with very clear requirements and you've already validated each of those requirements, then there would likely not be much uncertainty and thus minimal need to change the application as we learn more. Second, if you have stable requirements, that is, requirements that will not change over the life of the project, then the value of an adaptable architecture would likely not be justified by this cost. However, I feel compelled to point out that I have yet to see a project of any significant complexity in over 17 years of professional experience that has met both of these first two criteria. This may be the case with very small, simple, and disposable applications, but it's unlikely to be the case with large and complex applications with a long life cycle. Finally, it's important to be aware that there are obviously limitations to the flexibility of clean architecture. It can't work miracles, but it's still significantly more adaptable and maintainable than any of the more traditional styles of architecture I've worked with over the years. Now let's discuss where to go to learn more about the topics we discussed in this course. I have a great list of books, courses, and websites that will help you go beyond what we've covered in this course and take your skills to the next level. First, regarding recommended books, Martin Fowler has a book called Patterns of Enterprise Application Architecture. This book covers many of the patterns that we discussed in this course and laid the early groundwork for clean architecture practices. It's a great book, in fact, one of the best books I've ever read on software architecture to date. It was originally published in 2003, so while it's a bit out of date, it's still a great source of information. Next, Robert C. Martin, aka Uncle Bob, is working on a new book called Clean Architecture, which at the time of the creation of this course has not been released yet. However, given how influential Uncle Bob has been in the clean architecture movement and the quality of his previous books and architectural insight, I imagine this book will become the new standard text for this style of architecture. Third, Eric Evans' book Domain-Driven Design is a must-read if you're dealing with a large or complex domain. It provides a set of patterns and practices that will help you to deal with domain complexity. In addition, the whole book is a compelling argument for why you should implement a domain-centric architecture if you have a complex business domain. Finally, if you're interested in learning more about dependency injection and using IOC frameworks to resolve dependencies in your code at runtime, Mark Seaman has a great book titled Dependency Injection in .NET. While the examples are specific to .NET, this book does the best job I've seen to date of explaining the dependency injection pattern and inversion of control frameworks from both a conceptual and a practical standpoint. Next, for additional, more in-depth courses on Pluralsight, the following courses may be of interest to you. Domain-Driven Design Fundamentals by Julie Lerman and Steve Smith covers the fundamental concepts of domain-driven design. Domain-Driven Design in Practice by Vladimir Kurakov provides an in-depth walkthrough for applying DDD practices to your application. Modern Software Architecture by Dino Esposito covers domain models, CQRS, and event sourcing in more detail. Microservices Architecture by Ragdaman provides in-depth coverage of microservices. And Dependency Injection On-Ramp by Jeremy Clark provides a great introduction to dependency injection in IOC frameworks. Third, I have a few recommended websites. While I've tried to put links to the sources of information in each of my slides, there are a few additional links that might be of value to you. First, Martin Fowler, the author of Patterns of Enterprise Application Architecture, has his Blicky, which is part blog and part wiki, which provides more up-to-date architectural patterns and practices. In addition, Greg Young and Udi Dahan are the two biggest names in CQRS and event sourcing right now. At the time this course was created, I am unaware of any books on either CQRS or event sourcing that I can recommend, so for the time being, Greg and Udi's articles on their respective websites are the two best sources of information on CQRS and event sourcing that I'm aware of. Finally, my website contains additional information on clean architecture patterns, practices, and principles as well. I have articles, videos, presentations, open source sample projects, and links to additional resources available. In addition, if you're interested in implementing the screaming architecture practice in ASP.NET MVC, I have a step-by-step tutorial on that subject as well. So be sure to check out all of these excellent sources of information to learn more. Before we wrap things up for this course and for the series as a whole, feedback is very important to me. I use your feedback to improve each and every one of my courses. So please be sure to take a moment to rate this course, ask questions in the discussion board if there's something in this course that you didn't understand or would like me to clarify, leave comments to let me know what you liked about the course or if you think there's something I could do to improve upon for future courses, and feel free to send me a tweet on Twitter if you liked this course or would like to provide me with feedback in public as well. You can find me on Twitter at Matthew Renzi. Also, there are plenty of additional clean architecture patterns, practices, and principles that we didn't have time to discuss in this course. If you found this course valuable and you'd like to see a follow-up course, including advanced patterns, practices, and principles, please let me know. As long as I know that the follow-up course would be valuable to enough people, I would love to create it. And if you found this course valuable, please encourage your coworkers and peers to watch it as well. It will be much easier to get everyone on board with trying these architectural ideas if everyone has an in-depth understanding of them and their value as well. In summary, in this course, first we learned that clean architecture is a philosophy of designing architecture for the inhabitants of the architecture, not for the architect or the machine. Next, we learned that domain-centric architectures put the domain at the center of our architecture because the domain model is essential to the inhabitants of the architecture. Then, we learned about the application layer and how adding it places focus on the use cases of our system, which are essential to the inhabitants of our architecture as well. Next, we learned about command query responsibility separation and how it allows us to optimize both the command stack and the query stack of our architecture. Then, we learned about the screaming architecture practice and how we can use it to organize our classes, folders, and namespaces via functional cohesion. Next, we learned about bounded contexts and how we can use them to horizontally partition our architecture into microservices. Then, we learned about testable architecture and how clean architecture makes testing easier, not harder. Finally, we learned how to evolve our architecture to reduce risk due to uncertainty and changing requirements over the life of the project. Thank you for joining me for this course on clean architecture.